Okay, let me do an example about finding the intersection between two planes so that you see how this can be done. In fact, in a sense, it's easier than finding the intersection between two lines that we discussed a couple of videos ago. Let's say that the planes are these two. Now, the reason why I know that these two planes will intersect is that the normal vector for the first plane is 2, -1, 3. The normal vector for the second plane is 1, 1, 1, and those are not multiples of each other. So this is similar to the statement that two lines that are not parallel always intersect on the xy plane. Two planes which are not parallel to each other need to intersect on a line. So this is what we're about to determine. So you should think of one as being this one. Maybe here is 2, -1, 3 as a normal vector, and you have this other plane one, 1, 1 as this other normal vector, and we want to find this common line of intersection. And the point is that something on this line so let me just say first, writing words that they intersect. Since the planes are not parallel. Moreover, a point of intersection must satisfy both equations. So, must satisfy both equations if it belongs to the line of intersection. So for example, you can take the first equation to say that 2x plus 3z minus 5 equals y, right? So you can, the point is use one of the equations to solve for one of the variables and then substitute in the other equation. And then if you substitute in the second equation, you get x plus y, but now y is 2x plus 3z minus 5, and that plus z equals 1. And so that gives you 3x plus 4z equals 6. And so, for example, that tells you that z equals 6 minus 3x over 4. On the other hand, so that writes z as a function of x, and y, which was this thing, what does it become? Y becomes 2x plus 3z, but z is now 6 minus 3x over 4. minus 5. So the point of doing this is that both, well, I mean, I guess I could try simplifying this a little bit so that it doesn't look so ugly. So let's put a 4 here. So you get 8x minus 9x. So you get minus x. And then you get 18 minus 20. So minus 2. The idea is that now all the variables are in terms of x. So what is a point x comma y and comma z on the line? Well, x is still x. Y is now negative x, negative 2, or minus 2 over 4. And z equals 6 minus 3x over 4. So what you just did is write everything in terms of x. And now what I'll split this vector into two vectors, one involving everything related to x and the other that has nothing, which has x. So there's, let me put first the constants. So this is like 0 plus x, so I'm putting 0. This is negative 2 over 4, which is minus 1/2. This is 6 over 4, which is 3/2. And then this, the other stuff has x everywhere, so it has x minus x over 4 minus 3x over 4. Right, so the point is, it may be even better if I don't simplify so that it's more obvious. Right, so the point is that if you add up these two vectors, you get the vector from above. And now, the idea is psychologically called xt, and this is just for psychological purposes, because that makes it look more like the usual equation of a line. And so you find that every point x comma y comma z has a form 0 minus 2/4, 6/4, plus x. You can factorize an x because it's everywhere on this vector, but you factorize it as a t. And so you get 1, negative 1/4, negative 3/4. Okay? And that's like the equation r of t of a line, because notice that this is point plus t times a vector. So this is the equation we were after.